Picture yourself standing 200 feet beneath the French countryside, inside a tunnel so massive it stretches 56 miles in a perfect circle beneath Europe. This isn't just the world's biggest machine, it's humanity's most ambitious attempt to build an actual time machine that recreates the birth of the universe. The future circular collider could come online around 2045. And when it does, it will smash particles together with such incredible force that it literally rewinds cosmic history to a trillionth of a second after the Big Bang. Imagine trying to build a single continuous underground highway that stretches from New York City to Philadelphia, except instead of cutting through surface terrain, you're boring through solid rock 200 feet beneath the Earth, creating a perfect circle that must be precise to within millimeters. This is the engineering reality of the future circular collider. The 91-kilometer tunnel and related facilities demand careful civil engineering planning, with construction potentially beginning in the mid-2030s. The preferred design settles on a ring circumference of 97 kilometers with shaft depths ranging between 50 and 500 meters, the result of analyzing over 100 different scenarios before committing to this option. To grasp the sheer audacity of this engineering feat, consider that you could drive the entire circumference of this underground ring at highway speeds, and it would take you nearly an hour. The current Large Hadron Collider, with its 27-kilometer circumference, is currently the most powerful particle collider in the world, but this new machine will be more than 3 times larger, creating a subterranean racetrack so vast it could encircle the entire metropolitan area of a major city. The construction process itself reads like science fiction made real. Engineers won't dig a massive trench across the French and Swiss countryside. Instead, they'll deploy colossal tunnel boring machines, mechanical beasts the size of apartment buildings that chew through limestone and sandstone at a rate of about 30 feet per day. These underground leviathans will work simultaneously from multiple access points, carving out a tube 15 feet in diameter with surgical precision, leaving the vineyards and villages above completely untouched. But why does this machine need to be so monumentally large? The answer lies in the fundamental physics of steering particles traveling at 99.99999% the speed of light. Imagine you're driving a car at 200 miles per hour and trying to navigate a sharp turn. The centrifugal force would send you flying off the road. The same principle applies to subatomic particles. At near-light speeds, they experience immense forces that want to fling them outward from their circular path. The 56-mile circumference creates such a gentle curve that even particles moving at cosmic velocities can be held on track by superconducting magnets, building energy with each revolution until they reach energies that dwarf anything nature has produced since the Big Bang itself. This underground infrastructure will exist beneath entire communities for decades, with 8 surface sites and 4 experiments connected by this subterranean superhighway. Yet the rock and earth above will serve as a perfect natural shield, ensuring that life continues normally on the surface while humanity's most ambitious experiment in cosmic archaeology unfolds in the depths below. The future circular collider doesn't just build a bigger racetrack. It transforms into the most sophisticated particle steering system ever conceived, using electromagnetic fields to accelerate and steer particles, with radio frequency cavities boosting the particle beams, while magnets focus the beams and bend their trajectory. A single proton begins its journey from rest. In the first few moments, particles repeat the same circuit for as long as necessary, getting an energy boost at each turn, but the physics becomes increasingly dramatic as speeds climb toward the cosmic limit. To accelerate something from rest to 99% of the speed of light is just the beginning. Reaching 99.9%, 99%, 99.99999%, and 99.99999% requires exponentially more energy with each additional decimal place. The 56-mile circumference becomes absolutely critical at these extreme velocities. The more energy the particles have, the more powerful the magnetic fields have to be to keep them in their circular orbit. The future circular collider solves this by making the curve so gentle that particles traveling at 99.9999999% light speed can maintain their path without breaking free from magnetic control, a gentleness that only a 56-mile ring can provide. In just 1 second, these accelerated particles complete approximately 3,700 laps around the entire 56-mile ring. To put this in perspective, imagine a car traveling fast enough to circle the entire circumference of Manhattan Island 3,000 times in a single second, except these particles are doing it while threading through a tube narrower than a drinking straw, guided by magnetic fields that must be precise to within fractions of a millimeter. The energy buildup is staggering. With a center of mass collision energy of 100 TeV compared to 14 TeV at the current LHC, the total energy value reaches 16.7 GJ, nearly 30 times greater than the present LHC. When these particles finally collide head-on after their thousands of high-speed laps, the impact contains enough concentrated energy to recreate conditions that haven't existed in our universe since the first trillionth of a second after the Big Bang, the moment this machine is designed to reach back and witness. Given that these particles will be completing over 3,000 laps around a 56-mile ring every single second before collision, do you think the engineering precision required sounds more impossible or inevitable? Drop your answer in the comments below. Now let's dive into what actually happens when all that accumulated energy finally gets unleashed in a head-on collision. When those particles finally collide after their thousands of high-speed laps around the 56-mile ring, something extraordinary happens that transforms this underground machine into humanity's most powerful time machine. Not science fiction, but actual physics that recreates the precise conditions that existed in the first trillionth of a second after the Big Bang. Two protons traveling at 99.99999%, the speed of light, collide head-on, each carrying the energy equivalent of a mosquito in flight, but concentrated into a space a billion times smaller than a pinhead. The impact generates temperatures reaching 5 trillion degrees Celsius, more than 300,000 times hotter than the core of the Sun. This recreates the exact energy density that enabled elementary particles, such as electrons, to gain mass a fraction of a nanosecond after the Big Bang, allowing atoms and thus structures to form. In that microscopic fireball lasting just a trillionth of a second, the future circular collider essentially reverses 8 billion years of cosmic evolution. The collision chamber becomes a window into the primordial universe, when space itself was filled with a seething soup of pure energy, so dense and hot that matter as we know it couldn't even exist yet. For that fleeting instant, scientists are literally watching the birth of reality unfold in real time, observing the fundamental forces and particles that would eventually cool and condense into stars, planets, and everything we see around us today. But the most mind-bending aspect of this cosmic archaeology involves theoretical particles that might make actual time travel possible. If the collider succeeds in producing the Higgs boson, some scientists predict that it will create a second particle called the Higgs singlet, at the same time. According to this theory, these singlets should have the ability to jump into an extra, fifth dimension where they can move either forward or backward in time and reappear in the future or past. The physics behind this time travel theory sounds like science fiction, but it's rooted in M theory, a mathematical framework that requires 10 or 11 dimensions instead of our familiar 4. The proposed Higgs singlet responds to gravity but not to any of the other basic forces, which would theoretically allow it to slip out of our three-dimensional space and travel through hidden dimensions where the normal rules of causality don't apply. The test will be whether physicists monitoring the collider begin seeing Higgs singlet particles and their decay products spontaneously appearing before the collisions that produced them. Detecting the aftermath of a particle collision before the collision actually happens would be evidence that information traveled backward through time via these exotic particles jumping through extra dimensions. While these theoretical time-traveling particles couldn't transport humans or objects through time, they could potentially allow scientists to send data into the past or future, creating a form of temporal communication that would revolutionize our understanding of causality itself. The 56-mile underground ring wouldn't just be recreating the Big Bang. It would be testing whether the fundamental structure of space-time allows for information to flow backward through the cosmic timeline. The invisible 95% of our universe, dark matter and dark energy, comprises everything we can't see, but know must be there because their gravitational fingerprints hold entire galaxies together. The future circular collider isn't just designed to recreate the Big Bang, it's humanity's most sophisticated trap for the most elusive quarry in existence: dark matter and dark energy, the mysterious substances that make up the cosmos we cannot touch. Dark matter alone accounts for 85% of the universe's mass, yet it remains invisible and undetected. It acts as the invisible framework that holds galaxies together and shapes the universe. Because it doesn't emit, absorb, or reflect light, scientists cannot detect it with traditional methods. Current dark matter detectors, like the Lux Zeppelin experiment buried a kilometer underground in South Dakota, have been searching for years with unprecedented sensitivity. The LZ detector completed the largest dataset ever collected by a dark matter experiment between March 2023 and April 2025, but found no evidence yet for weakly interacting massive particles, WIMPs, narrowing the possibilities for what dark matter could be without solving the mystery. This is where the 56-mile collider becomes a cosmic game-changer. When the future circular collider smashes particles together at 100 TeV, 7 times more powerful than anything we've ever built, it won't just recreate the Big Bang's energy conditions. It will force dark matter particles out of hiding by creating the exact environment where they first emerged from the primordial fireball. The machine operates on a profound principle. If dark matter was created in the universe's first moments, then recreating those precise conditions should create it again, right in front of our detectors. The collider's approach to hunting dark matter differs fundamentally from underground experiments that wait passively for dark matter to bump into detector atoms. Instead, the FCC actively manufactures dark matter by concentrating enough energy in a small enough space to cross the threshold where invisible particles spring into existence. When two 100 TeV proton beams collide, the impact generates not just the temperatures and pressures of the early universe, but potentially the exotic particles that populated that primordial soup, including the mysterious dark matter candidates that have eluded every detector on Earth. But the cosmic stakes extend far beyond dark matter detection. One of the main goals of the FCC program is to study the Higgs boson with extreme precision, up to an order of magnitude further than current experiments, with measurements of the millions of Higgs bosons produced at the FCC probing potential deviations from standard model predictions. The machine will create Higgs particles under controlled conditions, allowing scientists to measure this fundamental particle with a precision that could reveal whether our current understanding of reality is complete or just the tip of an iceberg. A central objective is to measure the Higgs boson's trilinear self-coupling with sufficient precision to test whether it aligns with standard model predictions or reveals deviations indicative of extended scalar sectors, potentially linked to the hierarchy problem or early universe phase transitions. If the Higgs behaves even slightly differently than predicted, it would signal that our universe operates according to physics we haven't discovered yet, potentially explaining why matter exists at all instead of being annihilated by antimatter in the cosmic beginning. The 56-mile underground ring becomes humanity's ultimate laboratory for answering the most fundamental question in cosmology. Why does anything exist? The machine's ability to recreate the universe's birth conditions means it can test whether the forces and particles we observe today are the complete story, or whether hidden physics govern the cosmic transition from pure energy to the matter-filled universe we inhabit. Every collision in that underground tunnel is essentially a controlled experiment in cosmic genesis, with the potential to rewrite our understanding of why the universe chose existence over nothingness. Standing above this underground ring in 2045, you'll know that 200 feet beneath your feet, humanity has finally switched on the most ambitious scientific instrument ever conceived. And in that moment, we're not just building a bigger particle accelerator, we're completing humanity's transformation from cosmic accident to cosmic archaeologist, capable of rewinding the universe itself to witness the birth of everything. This timeline represents something far more profound than another engineering milestone. It marks the moment when our species graduates from studying the universe as passive observers to actively recreating its fundamental genesis. When those first 100 TeV collisions begin producing temperatures 300,000 times hotter than the Sun's core, we'll be conducting controlled experiments in cosmic genesis, literally manufacturing the conditions that existed when the universe was a trillionth of a second old. Every collision becomes a laboratory test of why anything exists at all, instead of the pure nothingness that could have persisted forever after the Big Bang. This underground ring transforms into humanity's ultimate time laboratory, where the distinction between past and future begins to blur through the physics of extreme energy. The theoretical Higgs singlet particles that might emerge from these collisions could slip through hidden dimensions, potentially appearing in our detectors before the collisions that created them actually happen. If confirmed, this wouldn't just prove that time travel is possible. It would demonstrate that causality itself operates according to rules we're only beginning to understand. The operational timeline spans decades. The first phase would begin in the late 2040s for approximately 15 years, followed by conversion to the higher energy proton collider with commissioning in the mid-2070s and operations extending through the end of the 21st century. This means that children born today will grow up in a world where humanity routinely recreates the Big Bang, where we've potentially solved the mystery of dark matter, and where our understanding of reality has been fundamentally rewritten by what we discover in that underground tunnel. The 56-mile ring becomes more than scientific infrastructure. It represents humanity's declaration that we refuse to accept the universe as an unsolvable mystery. Every revolution of those near light-speed particles around the tunnel is a defiant statement that conscious beings can understand their own cosmic origins, that intelligence emerged from the primordial fireball specifically to turn around and comprehend the very forces that created it. By the time the future circular collider reaches full operation, we'll have spent nearly a century building increasingly powerful machines to smash matter apart at higher and higher energies, each one bringing us closer to recreating the exact moment when energy first condensed into the particles that would eventually become stars, planets, and life itself. This underground cathedral of science represents the culmination of that quest, humanity's ultimate attempt to answer the most fundamental question in existence. Why is there something rather than nothing, and what does our ability to ask that question mean for our place in the cosmic story that we're finally learning to read? Subscribe for more mind-bending cosmic engineering, and watch this next video about what happens when stars collapse into black holes.